Hello guys, I'm Alukosha. Welcome to my math tutorial section. And in today's class, we shall be taking a look at the examination style paper 4, Cambridge IGCSE Math 0580. Okay guys, this is actually the part 2 of my video, okay? Yeah, so if you want to, if you're wondering about the very first question, just go ahead and watch the part 1. Yeah, okay, so let's get started with the question. So now, here's the first question. The first question, right? So in triangle ABC, AB is 9 centimeter, BC is 7 centimeter, and angle ABC is 128 degrees. Calculate the length of AC. Okay, so the first task we have here is to go ahead and calculate the length of AC, guys. You can just go ahead with the triangle the way you like it. Okay, I think I like it like this. Okay, so guys, another thing is that this is not to scale. I'm just going to write N not to scale. So scale, that's it. NTS, guys, not to scale. Okay, so how do we label this? I don't know. The included angle is actually 128. So the included angle is 128. So let's just put the included angle here. So this will be B. So let's label like, let's go this way. A, B, C. If you like ABC, I don't want it, guys. Anyhow we like it, but I just want that B to be up. So okay, let's go this way then. A, okay, BC. So don't forget not to scale. So I can use many dimensions. It's not about how tall, how long the length is. Okay, so that's what I'm going to scale. Okay, so let's complete that. So 128, that's the included angle B. So that is ABC. Okay, so this is 128 degree. 128 degree. And BC, this is BC, and that is BC is 7 centimeter. Then I have AB, and that is 9 centimeter. Okay guys, when you have two given side with an included angle, then you can go for what? Cosine rule. Okay, so let's go ahead and label this uppercase B, then this will be side B, lowercase, this uppercase A, angle A, so this will be side A, and this uppercase C, that is angle C, so this will be side C. So let's go ahead with, let me just put this in rectangular box to separate this from my diagram, okay? Let me put the solution in. Yeah, it's not a bad deal, right? Okay, so yeah, cosine rule. So I'm looking for CA, side CA, so you can just go ahead with P square equals A square, okay, plus C square, okay, minus 2AC. 2AC is cool, cos of the included angle. So that is cos B. It's like cos B show, yeah, cos B show. Okay, cos B show, yeah, that's pretty cool, right? Yeah. So what is A square? And that's 7 square. 7 square plus 9 square. Yeah, I love cos B show. I love that. Yeah, cos B show. That's pretty cool, right, guys? Just go ahead and play. Why am I writing B? I've started playing already. Okay, sorry about that. So into 7, okay, into 9, then cos B. That's cos 128. Cos 128. Yeah, I hope I'm going to. Yeah, let's just write it 128. Sorry about that. It will be outside the box. Okay, so yeah, I think I should just go ahead and plug that in the calculator, and the answer display on my calculator screen should go inside the square root here. Okay, so let's take a look at that. 7 square plus 9 square minus 2 9 close. Okay, then cos sorry about that, cos 128 close bracket. So I have 207.5 something. Okay, so let me just I'm going to maintain this the answer display on my calculator screen, but I will just write this to, let's just take this to 3 SF. So 573. So then I can just go back to my calculator now, because the solution there is a rational number. So square root of where's my square root? So square root of the answer, square root answer equals to 14.407. So to 1 dp that is 14.4. So B is 14.421 dp, guys. 14.4. And the unit there is centimeter. That's beautiful. Okay, next question. The area of the triangle ABC. Okay, yeah. I have question B there, so let me just demarcate like this. I think I should be able to complete everything of it. Okay, so now area, yeah, the area now since you have two given side and one included and good, then you can go ahead with your this formula here. Area, that's half AB sine C something. That's what you have in textbook, but I need to work based on my label, so it can't be half AB sine C. So that will be half AC now. Based on my label, that will be half AC, two given side. So half AC, then sine of the included angle. So that will be sine B. Okay, it's relative, it depends on how you label, so that will determine how you're going to write your formula, guys. So that is half into 7 into 9. That is times, okay, sine 1 to 8. Sine 1 to 8. Dog, I don't like dog. Why are you tracking? What am I writing? 7, 9. This is 9, okay, half into 7, this is into 9, so about that. Okay, so yeah, I have half times 7 times 9 times sine 1 to 8 plus bracket equals 24.822. So to 1 dp, that is 24.8. So 4. Okay, so that's the so the unit is about cm square, right? Okay, so let's just go ahead before the next question. Let's keep this in rectangular boxes because our solution so far in rectangular. Okay, next question here. The marketplace in Newark, Nottinghamshire, is a rectangle PQRS. PQ is 105 meter and QR is 65 meter. So in corner S stands the church. So it is 40 meter high. Work out the angle of elevation of the top of the church from P and from Q. Guys, this is not funny. Okay, because this question is quite technical, right? Yeah. So it's form of three-dimensional problem. So let's take a look at how to complete this type of question, guys. You just need to listen and look at what I'm going to do now. So let's first go with the plane, and the plane is a rectangle, right? Yeah, the plane is a rectangle. Okay, let me quickly make this note again. I think I like to bring it down a little. So let me just bring it down a little. Sorry about that. So I'll be able to get this space there. So this is a plane, right? And I need to make this note up. So this is not to scale. So so you don't need to bother about the longest side of it, like that. So you don't need to take your meter rust. I want to take the measurement, guys. Okay, so yeah, this is what we have in here. So let me just go ahead with my plane. That is a rectangle. So and this is P. And this is that not to scale. I don't like the way I put it. So let me just take it because I don't want it to affect my diagram. So let me just put not to scale somewhere around it. Okay, antiques, not to scale. Okay, guys, don't forget this is not to scale. So let's go ahead with the label PQ, and this is rectangle, right? Okay, so you know the parallel side are equal, right? Okay, guys, don't forget this is rectangle. By implication, parallel side are equal. So for example, PS is equals to QR, and PQ is same thing as SR. Okay, so based on the information given, PQ, this is 105 meter. So this is 105 meter. So by implication, this one here will be 105 meter. Okay, sorry about that. I don't need to write the units, right? Okay, then PS QR. Okay, so QR is 65. So and that implies this also here will be 65. 65. Okay, so that's the first step. Now We're also told that in corner X stand the church. So this is corner X. So let me just use this. This is the corner. So corner that is 90 degrees. So the angle we put over there is 90 degrees. So you put this corner X, stand the church. And the church is 40 meters high. So this is the top of the church. This top of the church, right? Let's target T, guys. Sorry about that. I actually want to take this. Top of the church. Let's just target T. Okay. Top of the church. Okay. And this church is 40 meters. Don't forget it's standing on the plane, right? On the plane, on the rectangular plane, right? Okay. So definitely we're going to have something like orthogonal projection. Okay. For example, now, let's just go ahead with the question. So what are the angle of elevation? So angle of elevation, that is angle of looking up. So you can look straight. For example, if you are standing on the top of the church, you can look directly like this. This is the angle of elevation and depression is the angle made with the horizontal line. Okay, so this is the horizontal line, and for B, this is the horizontal line. So now angle of elevation, that's angle of looking up. So look up to the church. So that's the angle there, angle of looking up to the church. So look up, that's the angle there to the church. So that's what we have there. And it's equal to the angle of depression. So if you are standing on the church and you're trying to look down to P, so that's depression. So angle of elevation equals to angle of depression because that is alternate angle, Z angle, letter Z angle. So let's start this angle, the angle of elevation on the top of the church from P. Let's target theta 1. So by implication, this one here also is theta 1. Okay, we actually have a right angle here already. We have a right angle. Let me just complete my meter here. Let me just put meter here. I think it's cool. Let's put meter here. And this one is meter. Okay, so this is the right angle already, so I can actually complete that. What I'm going to do now, I'm going to complete all my solution in blues. Why blues? Sorry about that. Okay, let me just. So okay, yeah, let's try this space here. If I can't complete everything there, then I'm going to use this space here. If I can't complete everything there, then I'm going to use this space here. Why did I clean up? Sorry about that. Okay, I'm going to use because of your degree, right? I'm going to use this space here. Okay, yeah. Let's just start with this space here. Consider triangle P. Right angle triangle P X T. Okay, so you can see that this is opposite. This 40 is opposite to theta 1, and PS is the adjacent. So I can go for tan, so to our right. So tan theta 1. Tan theta 1. Don't forget that angle of elevation on top of the church from P equals to opposite, that is ST, and that is 40 meter, divided by adjacent, that is PS, and that is 65. I think I'll just plug everything in my calculator. So then theta 1 will be arc tan of that. Arc tan of 40 divided by 60. And that gives 1. So pick up your calculator guys. Arc tan, that is 40 divided by 65. Close the bracket. 31.607. So 1 dp, that is 31.6. 0.6 degree. So that's solution to Roman figure IPI B1. That's still sorry about that. Okay, so let's go for what are the angle of elevation on the top of the church from Q. Now plane PQRS. So we can have the angle Q. We need to find QS here. Okay, because QS, that is QS will be orthogonal projection of QT. So QS is orthogonal projection of QT. That is what I mean is that the angle, this angle here now, so the angle, this angle here the angle that T make with Q is the same angle as T make with the plane. I don't want to say that again. I'm going to come down here. So now we need this theta, this angle here. That's what we're looking for. Forget about orthogonal projection, guys. What am I doing? So this is theta 2. Let's label this one theta 2. Okay. So now if you consider theta 2, then I have angle of looking up 50. That's it. Yeah. Then we have this is 90 degree. Let me just write that. This is 90 degree. So this is going to serve as opposite. ST will be opposite, and adjacent to the QS. Okay. And this QS now, we consider the considering right angle QRS. So it's like hypotenuse. So QR and RS. So let's go ahead and we just have to using Pythagoras theorem. Let's go ahead and find out QS first. So let me just do that here. So QS squared. That will give us 65 squared. Okay, sorry about that. My space plus 105 squared. Sorry about that. So QS will be square root of the sum of the squares of 65 and 105. So pick up your calculator and do that now. So let me just put that in now. Let me just go ahead to 65 squared plus 105 squared first. So that is 15 to 50. So that's square root of 15 to 50. And that equals what? So square root of the answer equals to 5 root 16. 5 root 16. So therefore QS is 5 roots. Sorry about that. So QS is 5 roots. 16. Yeah, but QS is 5 roots 16, right? Okay, 5 roots 16. So we can now go ahead with QST, QST, and this is perpendicular. We are looking for the angle, sorry about that. So the angle of elevation of the top of the church from Q, and here is it, theta 2. So that will be opposite over adjacent. So we can still go with tan theta 2. So tan theta 2 equals to opposite, that is 40, divided by adjacent, that is 5 roots 16. Then theta 2 will be arctan. Arctan of that. Okay, I just need to manage my verb. 40 divided by 5 root 16. Sorry about that. So theta 2. I just plugged everything my calculator now. Okay, so arctan of that. That's pretty good. Yeah, that's pretty good. So nice one. That's the solution. If you like, you can fill it up if you don't mind. Yeah, so the solution here is 31.6, and here is 17. Okay, that's the end of this section, guys. Let's go to the next question. Okay, guys, here is the next question. Opposite side of the hexagon in the diagram are parallel and are in ratio 2 to 1. Okay, AB is x, CD is y, and FE is z. So write down the vector ED. Okay, guys, I don't need to read through the question. Let's just take it one after the other. Okay, so let's complete AI. Okay, Roman figure 1 first. Okay, let's go ahead and demarcate Yeah, so that I can be able to manage this board very well. Yeah. Okay, so now the first question here, that is AI. Yeah, AI. Okay, so what rather the vector or ED, and so let's just go erase ED. This is ED, and if you can see, ED is actually parallel to what? ED, the direction is a key, so let's just from A to D, and it's parallel to A, B. Okay, AB in that direction too, so it's parallel to this, and AB is X. Okay, number two, that okay, that they are ratio 2 to 1, so this is twice that. So you can just complete that. It's just a mark, right? So you don't need to waste much time there. So ED, I'll just write something like this. ED equals to twice, okay, scalar product, right? Yeah, of AB. And you can put your arrow here. So ED is twice AB. So we can conclude AD is 2 and AD is X, so that is 2X. So let me just put this. So that's solution to the very first question. Let's just keep that in rectangular box. That's pretty cool, right? Vector is quite simple, right? Okay, yeah, that's pretty cool. So let's go to the next one. Roman figure 2, II. Roman figure 2. So S shows that AC is 2x minus y. So let's go for AC from E down to C. Okay, so let me just use this one here. AC. This one we are looking for now. E to C. So AC, since this is the origin, so you move from now the origin as the position vector. Okay, so starting from E, so AC will be ED plus DC, so something like that. So let's just write that. So EC equals ED, and we have ED already from the first question. Okay, plus DC. Okay, don't forget that this C is opposite direction CD, so that will be minus y, something like that. Okay, so this is directional, so let's just go ahead and put the direction is a key. Always do that whenever you're solving question involving vectors. Okay, so yeah, so EC now, that gives us what? That equals, I don't need to write that again. So ED, and that's ED, we have that already, 2x. Then plus DC, and DC is minus, so we already know from vector rule and direction that DC we give is minus CD. Don't forget this, you know this already. So and that will be minus y because it's opposite direction of y. This is moving up. Okay, this is moving up. This one is moving up, so it's against y. So it's minus 1. That's minus 1. So plus minus y is same thing as minus 1. That's pretty cool, right? So proof that's what they are supposed to do. So let's put that in rectangular box also. Okay, next one. The Roman figure 3. I. Okay, this was to find the vector AE and CA. So let me just change my pen color now to blue. Okay, so we want to find the vector AE, so it's A down to E. So this is AE down here, AE. So you have it here. Okay, so that's AE. Let's just work with that first. Put it direction. This is moving down like this. And you start from A, so you can move down. You can move A, F, then against EF. That will be minus Z. Then move this way. Hope that is pretty cool. So that from this down there. Okay, so let's complete that then. AE equals sorry about, yeah, AE, yeah, equals AF plus FE. That's pretty cool, right? So if you don't mind that, let's just go ahead and put our direction. So from A to E, A to F, then F to E. Okay, don't forget that this AF is actually parallel to CD. Okay, so that will be twice, and it's the same direction. AF is parallel to CD and it's the same direction, so that will be 2y. Okay, then plus FE, and FE is against EF, so that's minus Z. Oh, that's pretty cool, guys. Guys, oh, that is pretty cool. So that's 2y minus Z. Can we put that in rectangular box? Then we continue to the next one. So let's just put that there. So next, we have to find what? CA. So still Roman figure 3. So CA. So let's take a look at that. From C to A. This is C here, and this is A here. So let me just use this also. Let's just go with this. So this is C down to A here. CA. That's CA. Okay. So let's just go ahead with the direction. So this is the arrow. So you can use this 2 here. Okay, so let's just go ahead with that. For some reason, my direction is somehow. Okay, just put it, yeah, like that. Okay, yeah, that's really cool. So CA equals to what? So from C, so you can move to CB, and it's parallel to this. Okay, so you can go with CB. Then from B down to A plus BA. Okay, let me just take my arrow and complete that accordingly. Yeah, so it's always good. Vector somehow. Why must you always put it the direction? Guys, but it's quite easy also. So just take your time. Okay, it's not about you. Okay, so CB. So CB is actually parallel to FE, and it's the same direction. You can see it's the same direction. So EF. So that should be Z. Right, that's it. So that's it. Then plus BA. I look at BA is against AB, so that will be minus X. Oh, that is pretty cool. Sorry about that. Yeah, that's pretty cool. Yeah, don't forget, I don't know, for some reason I just omit the ratio. Okay, so yeah, now see, that's twice of this, so that will be 2Z. Sorry about that. Okay, because I think that is ratio 2 to 1. Okay, so from the question, so 2Z, because it's parallel to this, to FE, so and it's twice. Okay, then we can now go ahead now, minus X, that is BA. Just the same reason here, BC. Okay, so it's minus X. That's pretty cool, guys. So let me just take that in rectangular box. Okay, yeah, we can go to the next question. That's 2Z minus X. Sorry about that. Yeah, okay, so let me do that again. Okay, so pretty cool, right? That's pretty cool. Okay, so that's 2Z minus X. Okay, so next question here. Write down in terms of X, Y, and Z, AE plus EF plus CA. So now this vector sum, this is an expression though. Yeah, okay. Expression, okay, this is an expression. So expressing your answer in the simplest form. Okay, so let's go ahead. So what AE? Do you have an AE before? Yeah, let's go and check. So I want AE plus EC plus CA. This is quite interesting. Do you observe something? Now, don't forget, from if you've seen some of my video on vector before, you look at this one now. This AE, this will give you AC. Okay, so now from AC, now this will give you CA. Sorry that the vector can If you want to form an equation, that will be equal to 0. Okay. So yeah. Now like a position vector origin. So it's going to give you like a position vector eventually. Okay, so yeah, let's just go ahead, and this is an expression though. Yeah. So what is AE? Do I have that? Yeah, I do. So this AE here, so that is 2y minus z. Guys, let me just go ahead and put in, let me just separate it. Okay, let's put in brackets. So I'm through with AE like that. So I know I'm through with AE. Then plus EC. Do I have EC? Yes, I do. 2x. So let's put that in bracket too. Okay, so let's go ahead now. EC, I have it already. So that's 2x minus y. So let's close that. Plus CA, I do. I have it. That's the last question. So that is 2z minus x. Okay, so let's collect all the, let's bring all the x together. 2x minus x, so that will be x. That is, this is 2x minus x, so that will be x. Let's bring all the y together. 2y minus y, that is plus y. Let's bring all the z together. 2z minus z, that is plus z. So this is an expression, guys. That's it. That's pretty cool, right? So I know what they ask us to do. Okay? Yeah, that's what they ask. Especially your answer is C plus 4. That's it. It's C plus 4. Yeah, let's put that in the rectangular box. Okay, next question then. Write down a vector equation which follows from result of part B. So vector, we want to this one as equation. Now let's just come back here now. So let me just give you something. Let's see why this. Now if we have this one here, the resulting vector from here is AC. Okay, the resulting vector here, because this cancel this, you just go ahead and look at this. So that's the resulting vector there. So let me just take that off. Okay, then AC now plus CA. So we have AC plus CA because this start and this is end and this start. So that will give me A, and that's a position vector, guys. So that's OA. So OA is a position vector, meaning that x plus y plus z is actually like from. So the result equation will be. Let me just put it there because this is actually 2 marks, so I don't need to bring it there. Let's go ahead and prove from there. Let's just leave that and do the stuff. There you go. Okay. So now next question now. So let's go ahead and do that. So that's just a good one. Question C. So what is the implication? Let's just go ahead. My board is lagging already. Okay, no problem. Yeah. So let's resolve this. I have AE. I want to take the first two plus EC so the resulting vector there will be AC. That's the first two. Then I have AC now plus, sorry about that, AC plus CA. The resulting vector there will be OA, and that's a position vector. So I can then conclude, and don't forget that I've been able to sum all this now. So mean that all this now, AE plus EC plus CA equals to OA. Guys, so that is clear, and that is a position vector. OA is a position vector. So I can conclude that X, let me just start with OA. OA is a position vector, that's from the origin. Okay? It's from equals to X plus Y plus Z. So the result equation implies this, OA implies this. The result equation is x plus y plus z equals to 0. So that's it. Pretty cool. Hope that is clear, guys. That's beautiful. So that's the resulting equation. Okay, next question, guys. Use the above result to determine whether or not BE is parallel to CD. Okay, B is parallel to CD. Where is BE? So B down to, whoa, that's a big okay. Let me use green for that, guy. That's a green line. Okay, so let's go ahead with that. Yeah, sorry about that. So I actually have BE already. Okay. Yeah. Do I have anything like that? Yeah. So let's just go for CD. Yeah, I have CD already. That is why. So let's go for BE now. So this one here. Okay, sorry. Okay, so BE, this one here. Growing up, you can see it, right? So it's actually parallel to CD, but now let's go ahead and solve. Okay, so let's complete that. Now I don't know the way you want to move, whether you want to move like this or you want to move this way. So it's relative. So for me, I think I'll go BAAF. Okay, I'll go BAAF way. So let's go this way. So yeah, let's just complete that in green. Oh, green is in good. I think it's cool. Yeah, it's cool. Yeah, you can see it, guys. So BE equals to, for some reason I'll put all the arrow there. Okay, so B equals to I don't need to waste much time again. I'll be BA, okay, plus AF, right, plus FE. Okay, sorry about that. Okay, so from B down to F, so you move BA, then F, then FE. Okay, so that's the movement. So now what do we have there? So that equals to, what is BA? BA is minus X plus AF. We have that already. That is twice. Where is that AF? Yeah, it's parallel to this, so that's twice. So that is 2y. Guys, hope I'm correct. Yeah, plus 2y. Guys, hope that is. See now, AF is parallel to CD, so it's twice. Okay. Then plus FE, and that is opposite direction. So let me just, that's minus. Sorry about that. So that will be minus. It's opposite direction of this. So that's minus Z. So that's what we have there. Okay, now, but I want to express BE in terms of y, because that's parallel to CD, and CD is y. So I should express BE as a scalar product of CD. So BE as a scalar product of CD, that'll be like a rational number times y, something like that. So the best thing is just to, from this equation, from C, let's just keep this one first. Let me put it, the solution, that's the solution, but that's not enough. Don't forget, it's not, because I want to express in terms of y. So just put this one here, keep this one, I'm not yet through. So let's go back to question C and make y substitute of formula there. So from C now, we can see that y equals to minus x minus z from here. If you want to use y substitute formula now, so I can write y, move z there, and move to the right hand side. So y from C okay, I don't know, my body is lagging. Okay. From okay, from solution to C. Okay, from solution to C, we can see that y equals minus x minus z. Okay, so let's just keep this one like this. So just keep it simple. I don't know, so sorry about that. Let me just put the rectangular ones. So these are from C. Okay, so now we can go ahead and complete the solution to this now. So now, meaning that BE, we can write BE now equals to 2y plus, then open a bracket, minus x minus z, and that is y, right? So that equals to 2y plus 1, and that equals 3y. So we can then conclude that BE equals 3, and what is y? CD. So we can express BE as a scalar product of CD. Therefore, BE is parallel to CD. That is the implication, guys. Game over. Okay. So that's pretty cool, guys. Hope you understand. That's pretty cool. So that's it. So let me just go ahead and put that in rectangular box. So that's the solution. Which one should I? Let me just put this in rectangular box because we need to confirm that it's 3y here. Then we also put this one there, which is the final answer. So guys, I don't need to put arrow everywhere, but you want me to do that, guys, no problem about that. So these are vectors, okay, so just put there, these are vectors, okay. Yeah. And this equals to a position vector. I think everything is pretty cool. So yeah, this one here, and this here, and this here, and this here. Okay, guys, that's the end of this. Yeah, that's the end of the question, guys. Let's go to the next question, guys. Hey guys, here's the next question. A rectangle has length 3x minus 8 centimeter and width 2x minus 7 centimeter. So the first task was to write down and simplify an expression for the perimeter of the rectangle. So let's just take it one after the other. Yeah. Okay. So let's go ahead with the first one. That's 6a. Yeah, 6a. I don't know when I'll be able to manage my board. I think I'm going to start. I'll start it. I think I can use this fix too. Okay, so guys, A. So let's solve here. A. Okay, so now what I'm to do here is to expression for perimeter, guys. You don't need to waste time with this one because I know that. Just go with your formula for perimeter. I'm going to have 2 into length plus width. Okay, what's width? 2 into length plus width. Okay, so that's pretty cool. You don't need to waste much time with this one. So that will be 2 into so what is my, so that is 3x minus 8, that is the length, then plus the width, that is 2x minus 7. So we go ahead and collect like time, so bring all the x together and the constant together. Then I have 2 into 3x plus 2x, that is 5x, and then minus 8 minus 7, that is minus 15. Then I can, this is actually good. Yeah, for me this is simplified form, but let's just go ahead and open up. So that will be 10x minus 30. Sorry about that. Okay, that's pretty cool. I have to, so just open up. We can, I think the examiner will go for either of the two. For me, I even prefer this upward, but yeah, it's pretty cool. So 10x minus 30. Yeah, that's solution to the first one. So let's go for the second one. B. Let's just go ahead and demonstrate. Let's just go ahead and demonstrate. Yeah. So I have to D. So now let's go ahead with B. Write down an expression for the area of the rectangle. So yeah, this is also pretty cool because this is a rectangle. So area is just length times width. So I'll just go ahead and multiply L times W. Okay, so that's done. So that's 3x. This one we need not to expand it, guys. I'm not going to expand it. I'll just leave it like that. 3x minus 8 into 2x minus 7. The only thing is that I need to include the units, so I will just go ahead and do that. So this will be centimeter square. Sorry about that. So that's that, and this one also the unit is centimeter. Okay, so let's go to question C. Yeah, so if the area of the rectangle is 91 centimeter square, I'm sure that 6x squared minus 37x minus 35 equals 0. So now if the area equals that, so this time around I need to expand this. So I'm going to use 3x to open up this one. So that will be that's 6x. I don't know. Let me just move let me just remove this. I think because that space will not be enough, so let me remove this line. Okay, so that will be 6x squared, this and this, so 3 times 7, that's minus 21x, then 8 times 2, that is minus 16x, 7 times let me take a calculator, sorry about that. So that's 56, okay? So plus 56. And that equals what? Equals, based on the equation, equals 91. So we should equate it to 91. Given that the area from D equals to 91. So then we have 6x squared. This is minus 37. Minus 21 minus 16, that's minus 37x. Okay, so 6x squared minus 37x, so 56 minus 91 equals to minus 35. So we've been able to prove that, guys. So equals to 0. Show that equals to 0. Because when you move this one here, then it equals to 0. The right hand side equals to 0. So that's solution to that, guys. Let's just go ahead and put all solutions so far. Rectangular box. That's D. Theorem figure 1. Theorem figure 1. Factorize 6x squared minus 37x minus 35. So we have to factorize what we have there. Guys, yeah, let me just write the equation first. Okay, x squared. 6x squared minus 37 x minus 35. So I'm going to use factor method. So I can go ahead and break 6 down, 6x here against x, 7, if I have 7 here now, 7 and 5, let's see, 7 and 5 here, this should be negative, no, so that will not work, so that will be 5 and 7, so let's have 7 here and 5 here, and what negative of this, so this is minus. Okay, so I think that is cool. So 6 times 7 is what? Let me see. 6 times 7. That is 42. 42. So minus 42 plus 5. Plus 5. I'm going to have here is, guys, you know how to factorize. So just go ahead and do use your method, guys. I think you guys are pretty cool with this method. I've used this method quite remember, so my video. Okay, so minus 7 equals 0. So if you expand this one, you should have this expression. Okay, it just asks us to factorize, guys. I don't know why I put equals to 0. So that's an expression. Okay, so that's that. So that's that. Cool. Yes, my yeah, this one. So this is the solution. Factorize. If you like, go ahead and use your quadratic formula completing the square, but factor method actually works. Okay, so that's it. Now next, solve the quadratic equation. That's Roman figure 2. So we want to solve this now. 1, 2, I. So I can equate it to 0 now since I have to solve it. So that's 6x plus 5 into x minus 7. Guys, this is 5, so that it's like 3. Let me just take it up and write it. Sorry about that. This is 5. Okay, this is x plus 5. Okay, into x minus 7 equals 0. And this point now, I think let me just go ahead and carve out a space for the last question. So I'm going to complete the last question here. Okay, so let's continue with what we have here. So then I have 6x plus 5 equals to 0. From there, x equals to minus 5 over 6, or x equals to 7. Okay, look at the dimension we have here. The dimension, if we have a minus 5 over 6 here, minus 5 over 6 means that the length will be negative and the dimension cannot be negative. So therefore, s cannot be minus 5 over 6. So the only solution, the only possible solution is such that s equals to 7. So let's keep this one here now. So that's the only solution that satisfies the problem we have there. So let's keep this one. So let's go with the next question now. Write down the length and width of the rectangle. So when its area is 91. So length will be 3 into 7. 3 into 7 minus 8. Okay, so what we have there? That's 21 minus 8 if I'm correct. So length will be 21 minus 8, and that is, guys, I just need to use my calculator, sorry about that. 21 minus 8. So that is 13 centimeters. So the length is 13 centimeters. And the width there is 2x minus 7. So that will be 2 into 7. Okay, minus 7. And that is 14 minus 7, right? So the width will be what? 7 centimeters. Okay guys, this is the end of this tutorial, and yeah, hope everything is pretty cool. Guys, just the glass paper weight consists of a cone mounted on an hemisphere. The common radius are 3 cm. The height of the cone is 4 cm. Given the volume of the cone, and that is 1 over 3 pi r squared each, and the volume of sphere is 4 over 3 pi r cubed, and the curved area of the cone is pi l, and l is the slant height. Okay, so and the surface area of the sphere is 4 pi r squared. So calculate the volume of the paper weight. Okay guys, don't forget that the paper weight actually consists of cone mounted on a hemisphere. Okay, so meaning that the volume of the paper weight equals volume of the hemisphere plus the volume of the cone. Okay, so yeah, let's go ahead and complete the task accordingly. Do I need to demarcate? Yeah, let's just go ahead and do that. Okay, so first now, this is your hemisphere, this one here. Okay, let's just do something pretty cool. And we have the height. This is center, so from here up, that is the height, and this is your radius. Okay, so that's pretty cool. So I can just have something. This is going to be perpendicular to something like that. Okay, and this is L. This is this line, and this is the height H, and that is going to be 4 centimeters. And we also have the radius, that is 3 centimeters. Okay, for now let's just leave this and continue with the task. Okay, now yeah, volume of the paper weight, I'm going to tag that VPW. Okay, I think it's pretty cool. So volume of the paper weight, VP, and W will give us that will be volume of let's go for the cone first. The cone plus and the volume of the hemisphere. Don't forget, hemisphere is half sphere. Can I put that as HS? So it should not be like a sphere. So let's just put hemisphere HS. Okay, so that's pretty cool. Let's go for the volume of the cone first. So let's go ahead and find the volume of the cone. So the volume of the cone, we have the formula for that already. Right. That's 1 over 3. This is given here as given here. Okay, so that's 1 over 3. Okay guys, don't forget you have the volume of the cone already, and it's given here 1 r squared each. So I'm going to retain my pi is irrational number, so I will use calculator pi. Okay, so I have 1 over 3. I will retain the power like that, pi like that, so about it. Times pi radius is 3, so 3 squared, that is 9. Don't use y 3 squared. Times 3 squared times h. Guys, I'll just run everything in calculator. I need not to do that though, because I know this is this will give me 12. So this is 12 pounds. Hope I'm correct, right? As this is volume, the unit will be cm3. Okay, for now, let's keep that. I'm not going to put it in a rectangular box. It's not the final answer, so keep it. Okay, so now let's go for volume of the MA square. VHS. That will be half volume of sphere, and the volume of the given sphere is this is volume of sphere is 4/3. So half into 4/3 IR cube, right? IR cube. Okay, so don't forget this is 2 here 1, 2 here 2, so that will be 2/3. I'll just count this, okay? So 2/3. Don't forget I'm going to retain the pi. Then we have the radius already, that is 3. So times 3 squared, and that is 27. 3 cube, that's 2. Sorry about that. So 3, this will be 9. So 9 times 2, that is 18. So this will be 18 pounds. And since this is volume, that will be cm cube, right? Okay, now the volume of the paper weight, based on the formula we have, that will be volume of the cone, and that is 12 pi. Sorry about that, something is missing there. Sorry about that. Where's my eraser? So this is actually 18 pi. So 18 pi. So 12 pi plus 18 pi. Everything is cube. Okay. Sorry about that. I just managed like that. So that is volume of the paper weight. That will be 30, right? 30 pounds. But we are not asked to leave our answer in terms of points, so let's just go ahead and use calculator to complete that. So just pick up your calculator now on. So 30 shift pi. So 30 pi SD. That is 94.247777. So let's just take to K 94.277. Let's just to the nearest whole number, guys. To the nearest whole number. That will be 94 cm. Okay, since that is the final answer, I think I can go ahead and put that in the rectangular box. Okay, so this here is now also the final answer. So let's go ahead and put the final answer in the rectangular box. Without solution to the A part of the question. So let's go to the B part of the question. Oh my, I'm sorry. That is from figure 1. What do you mean by A part? What's wrong with Caloko? Jumping. Yeah, I'm sorry, Dad. So yeah, Roman figure 2 there. Yeah, the surface area of the paper weight. Okay, so surface area of the paper weight. So I'm going to take that one SPW. That will be the surface area of the cone plus, sorry about that, plus surface area of the hemisphere. Okay, I think I can go for cone first. I have a solution here. So let's go for surface area of the cone first. And the formula is also given from the question. Surface area of the cone is given as pi RL, where L is the slant height. So let me go for L first, but let me write the formula first. Pi A times R, and that is 3. Okay, times L. So let's go for L here now. Okay, so if you look at this is a right angle, okay, and this is a hypotenuse, so you can use Pythagoras theorem. Can I complete it here? I think it's cool here too. So L square equals to opposite square plus adjacent square, that is 4 square, okay, plus 3 square. Therefore, L square will be, that's 16 plus 9. 16 plus 9, that is 25. So L will be square root of 25, and that is 5 centimeters. So you can do this 1 times 5. So surface area of the cone then is 15. Right. That is 15 pi. Now this is surface area, so the unit will be cm squared, right? Okay, this is not the final answer, so let's just skip it. So let's go for the surface area of hemisphere. Okay, I don't know, for some reason what okay, yeah, this hemisphere, my hemisphere should be something like HS, right? So let me just change it to HS. I don't know, probably I don't know what I just put something like that. So this hemisphere, right? So HS, okay, just to be consistent. Hemisphere. So surface area of hemisphere Okay guys, so the next is to find the surface area of hemisphere, and don't forget that we have a surface area of sphere already. Now surface area of sphere is 4 pi r squared, so hemisphere is half of it, so that is half into 4 pi r squared. So that is 2 pi r squared, right? So that will be 2. I'm going to be 10 pi. My radius is 2, so times 3 squared. So that's 9 times 3, that's 18. That's 18 pi. Okay, so the unit is square. Okay, so then the surface area of the paper today, that will be equal to sum of the surface area of the sphere, and that is, sorry, of the cone, that is 15 pi, plus surface area of the hemisphere, that is 18 pi. So I can pick up the calculator and do that. This is centimeter square. So 15 plus 18, 15 plus 18, sorry about that, 18 plus 15, so that is 33, no, 33 pi. So surface area of the paper width equals 33 pi. Okay, we are not asked to leave an answer in terms of pi, so let's just go ahead and use calculator to complete that. So 33 shifts pi, sorry about it, 33 shifts pi equals to SD 103.67. So surface area of paper width okay, surface area of the paper width, that is 3 pi, and that is equivalent to 103.67. So 103. Okay, surface area of the paper width is equivalent to 3 pi, and that is 103.67. Sorry, 103.67. And let's take that to the nearest side. CM cube, that would be 104. CM squared. Since that's the final solution, we can go ahead and put in rectangular forms. Okay, question B. 1 cm cube of the glass of the. So that the next question is B, right? 1 cm cube of the glass which the paper weight is made, weight 2.85 grams. Calculate the mass of the paper weight. Okay, so now this says that 1 cm cube. This is volume of the paper weight. Don't it? I think we have the volume of the paper weight from question. Volume of the paper weight. Yeah, this is 94 here. Right, 94. So we have the volume of the paper weight. So that's for question 1. That's the volume of the paper weight. So let's continue here now. So 1 cm cube of the glass of which the paper weight is made, weight 2.85 grams. Okay, so that 1 cm cube equals to 2.85. From the very first question, the volume of the paper weight is 94. So if 1 cm cube is 2.85 grams, then 94 cm cube will be 1. So what can you do to want to get 94? So just multiply this one by 94, and multiply this one also by 94. 94. And that is 267.9. 267.9. Okay, so that is 267.9 gram. So the nearest gram, guys, let's just take to the nearest gram. Sorry about that. To the nearest gram, that is 268. 268. To the nearest gram, that is 268 gram. Okay, let me just go ahead and put that in rectangular box. Okay guys, we've come to the end of our tutorial session for today. Okay guys, I'll just hold on and let me show you something.
Hello Aluko. Can you help publish the video? I'd like to go over it again after the class session. I will really appreciate if you can feature more GCSE, IGCSE examination style questions to enhance our learning. I mean, if possible, all contents required by the examination board for us to gain a deeper understanding of the syllabus, aims and assessment objectives.
Hello guys, immediately after this session. The video there are quite good numbers of maths, additional maths, ICT, robotics and coding videos on my YouTube channel that will help you guys enhance your learning. If you find any of my resources and contents useful and cool enough, just go ahead and click like. Also, do well to hit the red button to subscribe to my channel for auto update of subsequent videos. It's free. Love you guys. Do have a great day ahead. Now, let's end with this note.
Wake the streets up! Yeah! Yeah! Okay! Wake the streets up! Okay! Come on! Okay! Wake the streets up!